Hello and welcome to the AI Digest. My name is Joaquin and I am the host. With me today is Dan Eaton. Dan has more than 12 years experience in accelerated computing, machine learning, hardware analytics, and he has worked with some notable companies, Fortune 50 companies such as Microsoft, JP Morgan Chase, Amazon, Alphabet, AT&T, United Health Group, and the United States government. Dan, it's a pleasure to have you, and I really deeply welcome this interaction. Anytime I communicate with you, in a matter of 2 minutes, I get a response, and I got to get on that level. I really do.
That's awesome. Thanks, Joaquin, for having me. I really look forward to our discussion today.
And your area of expertise is in hardware acceleration and analytics. Um, Oh, did I fail to mention you're the chief sales officer of Speed Data? I think I did. Can you tell us a little bit more about what your role is at Speed Data and how that plays into your expertise?
Yeah, it's a lot of fun. I get to work with some of the world's biggest companies and enterprises to look at accelerating their data analytics workloads. So that's something that is a lot of fun and keeps me very busy and engaged. And yeah, it's a blast, absolute blast.
And you act as a solutions as a guide, as a consultant. When you engage with these companies, I think you're a really honest salesperson, and I just view you as a very passionate individual about the space that you're in. Um, would it help if we lay some stakes in the ground and draw up what some of the work is that you do?
Yeah, of course, and I appreciate that. Yeah, it's incredible having the opportunity to work with such innovative customers and partners, attacking some of the world's biggest problems in analytics, from fighting financial crimes and fraud to providing better personalization for um, people that are in the healthcare system, to drug discovery and optimizing supply chain networks. It's really engaging, and I'm super thankful for the opportunity to work with such great customers and partners. But yeah, love to hop in.
So all these different innovative companies, they come to you and they say we have a problem. Our computers aren't beefy enough, extensive enough, specialized enough. What is the problem that they come to you with?
Yeah, definitely. I think we're facing a perfect storm right now where data is increasing. There's more devices than ever before. There's more digital businesses with COVID causing a rapid digital transformation across all industries. At almost every business, even small and medium businesses, are now digital businesses creating more data. And we've got this explosion of data while our data centers are actually lower capacity and availability than ever before. I just saw in the Bay Area, data center vacancy is at 2%. Across North America, it's 6%. And we're seeing double digit growth projected. And then when you layer on top of that the advent of large language models and what that's doing for generative AI. Data is the fuel that fuels the engine of AI, and all these data pipelines that supply that fuel are already constrained, and we're going to see situations where there's a there's a trade-off. Companies are going to either need to figure out how to keep the number of uh, analytics, whether it's ad hoc analytics or operational analytics or kind of batch scheduled reporting They're going to need to keep their capacity the same, which most businesses are not willing to do that because they're not standing still. They want to gain new business insights on that data. So if they want to continue to grow and get these business insights, they're going to need to do one of two things. One is keep incrementally growing the compute infrastructure and the supporting data center infrastructure. In some cases, it's double digit, or even for a few companies that are very data intensive, triple digit growth. So those types of growth rates are incredibly constraining for technology companies and financial services companies and telecommunications companies. So if you
And,
keep if you
and
keep growing it and it's just investing more and more money, the thing that I always think about is there was an IBM commercial. I'm dating myself a little bit, but there are a bunch of knights sitting around a round table, and the king or the head of the round table said, "Well, I know what we need to do to the problem. We need to throw more money at it." And they show a trebuchet or a catapult launching gold at the enemy. So I think that's what people can do, or they can look at what is a more efficient way to solve this problem. And that's where I'm fortunate enough to spend a bunch of time looking at hardware acceleration. So in the past, I've looked at diversity of different workloads. Today at SpeedData, I'm very focused on data analytics and analytical databases and what companies can do to get an order of magnitude, and in some cases, two orders of magnitude better performance for their existing investments. And that's something that I think is really exciting because right now we're seeing hardware showing up to solve some incredible grand challenges. NVIDIA and AMD have lately been able to execute on GPU capabilities that are unlocking state-of-the-art, large-scale transformers and large language models. And I think that's the type of kind of net new capabilities that hardware acceleration offers. But it can also help you reduce your capital expenses and operating expenses for legacy workloads too. So it's a fun domain to be in.
so it's been, we've seen like neck breaking speed in the evolution of computing over the last 100 years. I mean, there are computers that took up a whole room, then they got it down to be in your briefcase, and then now you have it in your pocket
It's
or
amazing.
your wrist. Uh, some are trying to do the little clip. Now you have like a hologram that you can interact with. I'm not behind that, but the it's pretty interesting how people started out with building their own data centers. That was the way to go. If you want to do something complex, you would buy a bunch of servers, and you would have to have a system administrator configure them and evaluate the hardware and keep track of how you're storing your data. Not a lot of data, like floppy disks and all that stuff, the small quantity of data. But then everything got smaller and smaller and smaller and more powerful. And then cloud computing came aboard, and they're like, don't buy your own hardware, rent it on the cloud. It's more accessible, get it anywhere, no overhead. But now, as you said, with COVID and everybody jumping in and abusing the data centers that were created to make it accessible, we're back to the beginning where it's cheaper now to build your own damn data centers than it is to go rent the accessible cloud, right?
Yeah,
It's
I think it's a great observation, Joaquin, of the accordion of distributed computing and centralized computing. Kind of over time, in hindsight, it's really entertaining to see that with the moves from mainframes and mini computers to servers and desktop computers to cloud computing to edge computing, and now we're getting back to these incredible supercomputers. At Amazon reInvent a few weeks ago, they talked about a couple new AI supercomputers, one with NVIDIA's Grace Hopper chip, and having the capability of 65 exaflops. it's it's um it's just incredible to me.
I can't even wrap my head around how many bits that is.
Yeah. I can't keep the numbers exactly straight in my head, but Frontier, which is the largest supercomputer, I remember that being publicized in the last few years as passing the exaflop barrier, and now we've got cloud computers that are 50 times that, which is incredibly exciting, and I think it's something that will unlock a lot of new discoveries and insights for science and enterprise.
Can we take just a bit of a step back and just examine the anatomy of a computer so that once we delve into more of the specialized knowledge that you have, we can have the context and the glue to fully appreciate it? Um, so, as far as I'm aware, we've gone over CPU, GPU. I know of RAM. I know of long-term storage. Is there any other component? Would you like to just discuss those components in their own?
Yeah, for sure. Yeah, I think the modern computer is something that in some ways we're getting new capabilities and features, and just the march of Moore's law and Dennard scaling and all these fantastic uh, and laws and rules of thumb for the progress that we're seeing. But I think the most important thing for people that are looking at hardware and infrastructure for the first time is CPU being the jack of all trades. Um, x86 being the overwhelming standard. ARM now is making a really substantial play also
And
in the data center.
that CPU stands for computer processing unit. That's sort of the brain, right?
Yeah. It's central processing unit, and the way that plays itself out in most computers is you can think of it almost like the brain. So it it needs to do a number of different things and be able to uh, coordinate via traffic cop, but also take in data and then transmute that data based on instructions. Okay. Memory, so RAM is like fast off chip memory. There's actually on chip memory on the CPU that's even faster, but it's small because it's more expensive. It takes up space on the CPU itself. But the off chip memory is typically RAM. And then there's different classes of storage, which is higher capacity, cheaper, but slower than RAM. And so these different types of storage, you can think of them almost like in a tiering methodology, where for the most uh, the things that you access the most in your home office, you're going to have them
Shelves.
out late exactly, or laid out even on your desk. And I think of that as like RAM, the stuff that's right in front of you. You can access it really quickly, and then your file cabinets in the back are storage. And then if you're like most companies and you've got a tremendous amount of storage, it might look more like a, a library with all sorts of files. And so that's longer term storage. So there's different tiers of storage, and some of the storage is actually getting faster and almost moving towards uh, like a storage class memory, and being able to provide very high throughput and lower latency and cost than
And
memory.
GPUs, how's that different from CPUs?
Yeah, for sure. So GPUs actually started off as graphics processing units, and one incredible thing uh, that NVIDIA really capitalized on was people were not just using them for graphics, for gaming, and for rendering and things like that, but they looked at using those GPUs to do high performance computing. And so
Hmm.
there's some really cool stuff that researchers and scientists and hackers did with consumer grade graphics processor units. So they're initially intended for graphics, but the way that they were architected was you could process a lot of uh, vectors in parallel. So there's a lot of parallel computing applications that you could use this graphics card for. And NVIDIA built a library called CUDA that made that graphics card very accessible for developers to build accelerated applications across a variety of different domains. And in the kind of 2015 timeframe, we started to see convolutional neural networks beginning to really have a renaissance in the area of machine learning. And the GPU architecture was very amenable for accelerating an important algorithm inside of training these neural networks, back propagation. And so the GPU, just right out of the gates, was a really good fit as it existed for this new class of machine learning workloads. And then NVIDIA, being very sophisticated and aware of that, they were able to make incremental feature additions to their GPU architecture, making it even more performant for this class of workloads training neural networks. And then over time, as the industry moved from training being the main focus, uh, and they started deploying some of these models for real-time inference, they started looking at how to add features to actually be able to support inferencing on these neural networks. So not just training the network, but how do you take the trained model and then deploy it into a situation where it needs to serve real time requests, so or support real time transactions. And so that's been an incredible journey to see that and to see where we are today now with some of these um, uh, supercomputing clusters from NVIDIA and AMD that are at the scale of tens of thousands of these incredible GPUs with onboard memory that's now staggering. This week, AMD launched their latest GPU, and the memory is measured in terabytes, which is just incredible to me.
So I just want to go back to that GPU. I just in my mind when I think of graphical computing, graphical processing units, it's like a matrix, right? It's like a three-dimensional space where you can manipulate, as you said, vectors or bits. So if you were to slice that matrix into slices, you could compute per each slice, right? That's kind of why it allows you to do parallel computing. You can run multiple processes in that square box of information of power of processing capabilities. Is that how it works, or am I a little bit off the mark?
Yeah, the biggest thing to think about is um, the GPU and the CPU are um, they're common in some ways, but the biggest difference is the number of processing cores. So on a very high end CPU today, you will have um, you will have 96 or 128 cores on the very, very highest end. GPUs, however, will have many orders of magnitude more
I see.
cores. So
So
that's
each
probably
core can handle
the biggest difference. Yeah,
okay, each core can handle its own mini set of operations. Okay, cool. And we ventured off with neural networks, convoluted networks, graph neural networks. Now we're venturing into the space of machine learning and the larger umbrella of artificial intelligence. Can you tell us a little bit more about neural networks and then some of the other deep learning, like all the other adjacent technology groups?
totally, totally. And to kind of tie off that GPU and CPU discussion, um, the 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 big kind of difference in terms of the number of cores is GPUs. Imagine it's like a large group of people, uh, all working on different tasks. Um, usually you want to apply them to a massive task or project. So um, I'll kind of use an analogy. Say you and I have to paint the walls behind us. You've got a really cool texture on my wall or on your wall. My wall is pretty flat and boring, so maybe I gotta spice it up and paint it a cool color. If if I needed to just paint that one wall, I could probably do it myself in a small period of time. But if I was looking at painting my entire house, I might want to have multiple workers help me paint that. And so for those tasks that are kind of uh, you
Massive.
benefit from more workers. Yeah, massive, exactly. Like if you have to paint an entire house or even bigger, like a massive industrial building, and you could have a whole bunch of workers all working on and dividing that task. That's the best way to think of a GPU, and a CPU is more about handling small tasks very quickly and being able to context switch. Where like I could go from painting the wall behind me, go off into the kitchen and make my kids some dinner. Um, so that kind of flexibility and being able to do small things very quickly in a sequential fashion versus
Hmm.
large, massive
Yeah.
parallel projects. Yeah,
Hmm. Okay. Yeah, it goes back to that idea of the brain, right? You that's kind of like the conscience sequentially operating in real time. Whatever's in front of you, you react to it or proactively act to do something. But there's the subconscious or other mental processes that are kind of obscured in the background that help you think about how to break that down. And you know what? Let me just transition over to the AI. I think you did a fabulous
yeah,
job.
man. I was getting scared because you were wading into the depths of
Yeah, no, I was
like
going to go into
neurology, and I was like, oh man, this is going to get interesting. I was excited to hear what you're connecting the dots, but I think it does actually connect because when we look at neural networks and what's possible, I think today we're starting to see the real fruits of the latest stage of neural networks. So going back to AlexNet and YOLO and all these early ones, they were all about object detection and classification, um, identifying a coffee mug versus a cat. And I think those had very obvious applications um, because detection is something that historically computer vision has approached different ways, and neural networks were doing um, initially they were doing a similar job to existing computer vision algorithms, but they got really really good because you could train these networks if you had a tremendous amount of labeled data, and if you had massive resources, uh, tens of thousands of people actually supporting the data labeling. for you to take that labeled data and then train your neural networks. And that's something where I think it's easier for us to understand, slicing up an image and taking tiles from that image and having those tiles inform the weights of these neural networks. And it's a little bit more understandable, I think, for a lot of us, just because it's visual in nature.
Mhm.
But recently, with the breakthroughs in transformers and being able to do that with text, and being able to be very uh, good in terms of the general answers that these chatbots can provide. I think it's like a new era of AI, and I think it's transforming things, both from how we retrieve information. That's kind of um, I heard someone, and I apologize for not being able to reference who it is because it's certainly not my idea. But they talked about language being a projection of reality, and with transformers, we're able to essentially compress or retrieve that projection of reality by training these large language models. And it's really exciting because now uh, we can retrieve these compressed projections of reality, and it opens up doors for more people to get access to data than ever before. And it's super exciting. I think it's very promising, but it's still early innings. There's a lot of game left to be played. And um, I think one of the things that I I had some fantastic discussions in the last couple weeks with people on is um, uh, kind of the intersection of large language models and enterprise analytics. So large language models today show great promise for providing general responses. But when you get into things where general is not good enough and you need to actually get to the business specific data, that's where large language models need to be augmented with other technologies and combined with other technologies to be able to answer uh, enterprise questions. And that's something that is really exciting to me because companies like Microsoft and Databricks are building out all of the additional augmentations for these large language model enabled chatbots to be able to go in and build a semantic or ontological understanding of the enterprise data, so that then when someone interacts with a chatbot in a natural language way, the system can actually take that natural language query and then go in and understand what the relationships amongst the entities inside of their data are, and then provide a response that has a significantly higher degree of accuracy than just a large language model by itself. Where I think we've all experienced interacting with chat bots in the last year. Those times when you ask it a question, and if you know the answer, it's hilarious how wrong the answers sometimes can be. But it's a exciting domain for sure.
I think you're painting a pretty interesting picture, and I think you're speaking on the points that many people are talking about on on LinkedIn, that people have this innate fear of things that they don't understand. Artificial intelligence is coming after our jobs, um, but you just said to get a computer to differentiate between a coffee mug and a cat, it takes thousands of people to augment and support the training of a immature artificial mind, of artificial intelligence. And then we go to language models, and I've talked to some other people about this as well, especially with the podcast. I've had the opportunity to talk about LLMs because it's such a hot topic. It's a static representation of language, you know, because it's just whatever was able to be scraped and trained and put in a box. Like, here's the box that you can ask questions about. If, your question doesn't exist in the box, you're not going to get anything on that. It's not going to know how to interpret it. But I don't know. It's just we're still so reliant on humans being in the loop, humans being involved. But as you're saying, the trends are, as we keep working through these software and hardware challenges, the hardware, the investments in hardware architecture, the investments in hardware improvements are going to pave the way for greater efficiencies in how these machines can use human knowledge with less effort, right? That's kind of where we're going with this, with the trend.
Totally. And the way I kind of in my limited experience, what I bump into in this space is exactly what you said, where uh, we have new capacity and capabilities being freed up. So at the lowest level, um, the innovations in compute infrastructure in my domain, we're working on accelerating um, data analytics and in the context of data warehouses and analytical databases and AI pre-processing the data so that you can then feed it into your machine learning systems. And what we're seeing is orders of magnitude faster time to insight. So that means that the data engineering teams and data science teams can now do the same work in 20 times, or in some cases 200 times faster. So they become more productive. The systems themselves, the data systems, are producing results so much faster that it enables them to free up their time. As one data engineer last week told me, he's like, man, this all this data pre-processing stuff is not fun. I want to get to the insights. I want to get to the fun stuff. And that opens up productivity for the data engineers and the data science teams, that then enables them to answer questions that are today unanswered questions, or in some cases unasked questions. And that's really exciting, because if you can start answering questions that you couldn't before, or better yet, you can enable really smart people to ask questions that they didn't even have the audacity to ask, and get answers to those. That's when I think we will see, as you said in our discussion earlier today, almost a shift to a new era, where there's new eras. When new productivity is unlocked with technology, that productivity, if used in the right way, can unlock incredible new opportunities and advance us. Um, I I don't have a really um, informed perspective on AI safety and regulation. Um, I think it happens in past technologies. I see these things happen very slowly,
Hmm.
almost outside of our human perception uh, scale, where like our temporal scale is like right here, right now. But I see it happen over many years, and it's like, in hindsight, we can look back and say, wow, that was incredible. um, but yeah, I think it's gonna be sizable. And I think the new era, the new phase, I was trying to think about it, because we had the uh, agricultural economy, an industrial economy, high value industrial economy, then a services based economy today, that turned into an information services based economy. And it's like, I don't know what's next, but I can see there's a lot of really uh, incredible things that are happening, creating new capacity for some of these high value knowledge workers. So it's like when companies can leverage that and make sure that um, you're enabling uh, uh, smart people with new and interesting perspectives on the problems and opportunities that enterprises and governments face. I think it's really exciting. I think it's something that will lead to some breakthroughs.
So I think, in the examples that you gave in the beginning of the applications of hardware acceleration, there were some interesting things that we can talk about. But I would like to take it just even a little step back and say there's data, right? There's data, there's things that are collected with instrumentation, with processes that people run on, like they take pictures, or they have temperature sensors, or they have, I don't know, any other example, like seismic readings on like earthquakes and things like that. All that gets aggregated.
Totally. Log files. You
Log
think
file.
about the mountains of log files created, um, the all the transactions, all the digital transactions, telecommunications networks, just moving and routing packets all around the world. Some of the airborne sensors that are flying around, the density of the data being created from some of these sensors is
Oh,
now
right.
it's in the petabytes for single sensors, which is all this data, and most of it is unstructured data. Is in some industries, it's being just dropped on the floor,
It's
or
unwieldy.
being, yeah, it's like we can't handle it, so let's thin it, let's ignore it, let's just put it somewhere to rest in case we ever need it.
Hmm.
Um, but I think where a lot of the hardware acceleration can add value to that is, what are some things that you are doing today and it's so prohibitively expensive, um, but if you could drive down the costs of supporting that, um, that from an analytics or from a machine learning perspective, I think that's exciting. And then in some cases there is just true innovation, and people that are able to ask those questions that they just simply couldn't even ask. Like they couldn't ask the system um, to try to tackle some of the grand scale problems that we have. And I think there was a really exciting um, update in the area of meteorology. Uh, Google Google announced that they were able to outperform existing weather simulations by using graph neural network based solution that they developed. And it's like that has so many ramifications, where it's great, you're saving money in terms of your infrastructure, and you're solving things in a different way, which that's exciting. But the application of being able to better predict the weather for agriculture, for natural disaster planning, that's where it really gets impactful and exciting, I think, for humanity.
Within your role at Speed Data, I'm sure you're dealing with scientific and commercial applications. Is there any kind of particular use cases that jump out at you that aren't covered under an NDA that you're able to talk about?
Yeah, the one that I'm really excited about, that we're going to share a little bit more information on in the coming weeks, is a drug discovery use case, looking at compound similarity. So when pharmaceutical companies are looking at developing new drugs, they want to compare these compounds.
The shapes of those
And
compounds, right? I mean,
yeah, and you can imagine it's like a similarity a similarity is comparing one thing versus all other things. And
Akin,
all other
akin,
things in this case can be very large and very complex to do that. And so with traditional computing with CPUs, this was prohibitively expensive. So the similarity calculations would have to be done offline, costing hundreds of thousands of dollars of spot computing instances operating, and you would have to make a selection of how many compounds do you want to compare similarity against. So you could thin the number of comparisons made to reduce the cost and the time. But by using our hardware accelerator that's designed to do data analytics much more efficiently than a CPU, we're able to shrink that time dramatically. And the customer actually looked at not just shrinking the time because it's a batch workload, it can run offline, and that's okay. But what they were able to do is they were able to have uh, four of four of our uh, four of our chips versus 100 CPUs, and they could get the results 10 times faster. So they literally shrunk from 100 CPUs to four of our particular processors, and they could get results 10 times faster. It's kind of a have your cake and eat it too moment. But why I'm excited about that particular use case is in areas like drug discovery, where you're seeing actual innovations on the therapy side and targeting, especially in oncology. There's some very exciting stuff happening where therapies are getting very personalized and targeted to individuals and individual, um, uh, kind of leveraging the omics side of things. And that to me is exciting because it extends the people's lives and improves the quality of their lives. But there's so many different use cases out there across industries, from managing risk, helping financial institutions ensure that they can weather the next financial storm or crisis, and global macro trends that are accelerating, optimizing supply chains, building kind of next generation uh, product lifecycle management and product information management systems, to be able to understand these complex interconnected supply chains that are global. And
and dynamic
we
too,
use,
right?
yeah, for sure. We've done some things that have improved the efficiency of supply chains, like with just in time and all these lean manufacturing principles. But those have actually made managing the supply chains for folks downstream much more challenging. So the burden then gets put on the data analytics and the uh, capacity and demand forecasting and supply optimization. So I think those are also really exciting because they impact so many different companies across our global interconnected supply chains, as well as the consumers that consume the end product.
So technology that augmented the capabilities of humans to act and make decisions faster, and now we're reaching that throttling point where we're creating so much more data that we don't even know what to do with. Specialized hardware is paving the way for us to reclaim our ability to process that data and even gain superhuman insight into forecasting for the future and managing complex distributed dynamic systems like supply chains, that it's a bunch of chaotic actors acting on their own regard, trying to, move and grease the wheels across goods that travel from one place in the world to the next. I mean, that's pretty exciting stuff. Um,
Yeah, it's awesome. It's awesome, and that's an area where I'm energized and optimistic because I see what data scientists and data engineers and even people in the business on the analyst side are able to gain new insights, actionable insights, and to build more accurate predictive models to be able to innovate and do more with less and make better decisions faster. So that's it's an area it's very energizing. It's so much fun. I'm very fortunate to get to work with so many fantastic partners and customers and to get to talk to people like you about these things.
and you said that what's paving the way for this to be possible is some of the sizable investments that are being made by these Fortune 50 companies. You said up to $100 billion are going to be spent in the next couple of years to develop what manufacturing facilities, so you can manufacture specialized chips, or what is the investment going to go
Yeah,
to?
for sure, for sure. Yeah, I think there's an incredible fabric of capital investments being made across nations. Like the United States has made some really sizable investments in the CHIPS Act, revitalizing advanced semiconductor manufacturing in the United States. And Intel is doing some incredible things there. TSMC and Samsung are also building some advanced capacity for fabricating semiconductors, and that's something that's measured greater than $100 billion. On the data center uh, capital expenditure side, there's I think next year it's on the order of $250 billion of new data center capital expenditure. Amazon and Microsoft in Alphabet together are it's one of those companies announced greater than $50 billion of investment
Hmm.
in new data center capital expenditures, which is staggering. That's like a
Whole
state
country.
level
Yeah.
massive infrastructure project, like the program in the United States that we put together to go to the moon. That that's the scale of some of these large hyperscale technology companies and their data center investments. And then I think on the uh, kind of end customer enterprise demand side, I think people are increasingly moving to the cloud for those workloads that are a really good fit for the cloud, where they can scale up, scale down. Also for agility, that's what I hear most commonly uh, from kind of data officers and leaders of analytics is the cloud gives them that time to market and that agility and speed to bring something from idea into production so fast. And then on the other side, there's companies that are investing in massive ways in building out um, their kind of steady state. In the electricity industry, you'd call it base load. Those things that are consistent. It's going to be, you're going to be running your ERP system and your legacy transaction system of record, and so this thing is just running and it's steady, and you can predict to build a private cloud at a colo or your own data center and really make sure that you're getting the absolute lowest price for the compute infrastructure and storage and networking. And so I think there's a number of different dynamics at play, and huge investments in the actual fabrication of semiconductors, which I'm really excited about. I'm glad that that's happening. And then the hyperscale technology companies building capacity for this next wave of public cloud computing, and then I see a lot of companies also that are um, innovators in specialized clouds. So there's companies like CoreWeave and others that are saying we're going to build a cloud for almost a dedicated set of workloads that really need or benefit from um,
Specialized cloud
yes,
infrastructure.
like specialized cloud for a specific set of workloads, which I think is also really it's really interesting and can uh, further drive down the costs and reduce the prices for some of uh, the higher end compute infrastructure. And also the hyperscalers are continuing to innovate. Amazon reInvent launched uh, two new um, two new ASICs that they developed themselves. One for training neural networks and one that's for inferencing. They also announced their latest version of a ARM processor that they developed themselves. So it's like there's innovation happening even at the very largest clouds like Amazon and Microsoft similarly announced um, a a new ARM processor that they developed as well as a an AI training ASIC. So it's like it's um, it's an exciting time to be in the space of hardware acceleration and analytics and machine learning. It's really exciting.
So let me see if I get this if I got this right. Otherwise, please, I beg you correct my understanding. So you have the data, and data is collected by any sensor, any instrument. You give this data to a computer program that is meant to receive it, transform it, or use it, or transmute it, as you say, and there's an output. Um, when you're building models to represent the real world using data, depending on how much data is available, that processing to produce some sort of insight, to produce some sort of analytics, is unfeasible because of the sheer number of workers that can't handle the size of that gigantic wall, right? If we're sticking to that idea, it's just like you got to paint all the industrial buildings in all of the United States, and you have 100 people. You're not gonna do it, and if you are, it's gonna take a ton of time, and it's not gonna be efficient or enjoyable for those workers. But if you had a million workers, now it becomes something that you could do in a faster period of time, and you could break up the task a little better. Um, Now you mentioned machine learning. So machine learning is teaching a machine to consume data and produce some sort of useful result that you can then use as information for humans to make decisions, right? That's
Definitely. And the way that I kind of break down this ecosystem around, you've got on one side sensors and raw data, and then
Mhm.
you've got to ingest that data into some type of system. So there's the data ingestion, and you use CPUs and memory and storage to ingest that data. So that's kind of the first step, and that's something that there's lots of technologies out there to do that, to kind of capture and then ingest the data. Then you need to store it, and you have to have some type of place to store that: object storage, file storage, blob storage. Um, and so now you've got the data. For some of that data, the vast majority of it's unstructured or semi-structured. For some of that data, it's important for your business to understand how everything's connected. So you want to structure it in some way. So there is a process to essentially take that unstructured data and transform it um, into a structure. So like when people use um, Excel to go in and put your Christmas card list together, or whatever you're doing in Excel for work. Uh, what what you're doing when you're actually building those rows and columns is kind of similar to what you need to do when you structure the data, which is you take individual pieces of data and then make it consistent and uniform, and what are the particular relevant fields, how do the entities inside of that data relate to one another.
Mhm.
And so once you've got that data uh, stored in a structured format, then what you can do is you can process it, and you can go in and ask questions of that data. You can do um, periodic, consistent things like for reporting, where you know what report you need to pull if you're a business for um, reporting to regulators, or announcing your kind of quarterly financials, or just for executive dashboards. But then there's also some ad hoc analytics that people will want to do um, as their business evolves and changes, and you want to ask questions of that data, so you can apply kind of ad hoc analytical queries. Then once you've got that data, and it's transformed into the way that you want it to be, representing the kind of entities and relationships inside of the data, then you can also take some of those um, processed pieces of data and hand them off to your machine learning pipelines or your business intelligence tools, or you can have end users interact with those kind of curated reports. So it's all of those stages of kind of the journey of data. They're all enabled actually by those same things that we talked about from an infrastructure level:
Mhm.
compute, RAM, storage, networking.
It's just
All
more specialized architecture or beefier capabilities, but it
Yes,
boils down to
there's slight differences in the mix of what you need for each stage of that journey of data. And on the machine learning side, that's where you see, we talked about it earlier, how GPUs are very, very amenable for some of the machine learning and training the neural networks, and applying some of these machine learning algorithms. And then on the like on the kind of early side of this data journey, where you're ingesting the data and you're bringing it in, that's something that a CPU does a really great job of. And there are also some innovations that people are doing on the networking side, with building network accelerators to be able to support having more and more of those IoT streams be able
Mm.
to be ingested in parallel. So it's throughout that data journey, there's always a commonality of infrastructure underneath each step in that data journey.
Mhm.
But what we're seeing is more and more specialization for certain steps. And I think it's a natural and logical progression.
And all these developments in hardware and investments are paving the way for more accessible processing units, right? You could go and purchase these chips eventually at Best Buy, I would imagine, but clearly, like
Yeah, and
maybe 10
to-
years from now, right? But sorry.
totally. I think that's something that's exciting for uh, people that are technology enthusiasts. Is um, we we are seeing consumer and desktop versions of these innovations. Um, Recently, Apple last week announced a new library for the neural engine on Apple's M2 processor, ARM processor. which is going to be more performant when you're running those local machine learning workloads, doing stable diffusion or whatever tickles your fancy. And I think consumer grade GPUs are also even more kind of prevalent in terms of people using them to do really cool things. And for a few $1,000, the computational capability is not that far off some of these very expensive data center grade devices. And that's really cool because uh, I see I see what builders and makers and hobbyists are able to accomplish now, and it's really fun and exciting. And um, I think that's something too that the cloud will democratize access to hardware acceleration, and all sorts of technologies that run on top of it, because you can access some of these very expensive computers for just a
dollars.
billed at the hourly and now the second basis for some services. It's incredible. But you can also get access to consumer grade uh, desktop uh, desktop CPUs, and AMD recently announced to some of uh, the AI engines that they're building into their desktop CPUs, which it's a cool time to be a hobbyist and to be a builder.
I'm excited because I've seen the transition from, playing around with a little breadboard, and plugging in little pieces of wires. And then I saw Arduino come in the scene, and people are like, "Yo, now you can plug in wires, but you can plug it into your computer, and you can do like a rough, soft circuit." And then that went to Raspberry Pi, and now you're like, "Okay, let me do a Python script and combine hardware with software in a very humble way." And now, you know, damn, we got dynamite in our hands with these very powerful computing devices that allow us to do laboratory grade scientific applications for $1,000. That's unheard of. And
It's
like,
so cool.
who
Yeah,
knows what's gonna happen 10, 15, 20, 30, 40, 50 years from now? Are we gonna
it's
get
it's hard.
Jarvis?
I
I don't
I sure hope so. I'm looking forward to that. I I think one thing I would also like is a laundry robot. So that might be a different topic, but I think someone needs to build a laundry robot.
that folds it and puts it away for you, right?
Yes, yes.
I'm behind that. Let's put it out into the universe, and maybe somebody will approach you for a special.
Yes. So someone listening might take on that grand challenge.
Well, Dan, are there any parting words that you'd like to leave anyone listening in with on, hardware analytics, or, if they're encountering any challenges where they just have a, you know, just bleak amount of storage that they don't know what to even do with, and their hands are tied and they're tired of waiting 2 months to get the one process done. What would you like to tell them?
Yeah, I mean, if someone's in the area of data analytics, and you've got some batch analytics that is either too costly or takes too much time, or your compute infrastructure has to grow 3x every year to support it, reach out to me on LinkedIn. Happy to chat with you, and even if our even if our discussion grows beyond the scope of that, happy to engage. And yeah, really appreciate the discussion this afternoon, and it was a lot of fun catching up. And yeah, I think it was a lot of fun. Look forward to chatting with you further.